Hello everyone. Today we will be covering that sewage disposal. Now, the sewage disposal is a very important topic in the sense that essentially when we say sewage disposal, it is the disposal of the human waste. And human excreta, as all you know, the source of infection. That is also causing sewage, soil pollution. Water pollution is also there, and contamination of the food sometimes. And of course, the vector breeding is also one of the reasons the sewage disposal is not there. So, sewage disposal, why we cover the sewage disposal? Because there are two things are there. Number one is the safe disposal of the sewage, human excreta, that is the sewage. And another thing that nowadays things are changed now. The sewage disposal, the treatment of the sewage, and thereafter what they are doing, polishing it to that extent that it is as good as you can say the usable drinking water. That is primary, secondary, and tertiary treatment is now there. So you are being able to recycle the complete water. It is not even that wasted. That water is not wasted. You can reuse it. So that is the advantage of the sewage disposal. Now from the situation in India. Situation in India is something you can say, something like you can say ki intestinal infections are very common. The burden on the community is also there, and the treatment cost is also there. And even today, 60% population is in a rural area. And open air defecation is a very big issue. Although the Swachh Bharat Abhiyan in last 2 years has made a lot of difference, but nonetheless, it is again open air defecation is still there. Then Sulabh Shaushalaya has made some difference in there now, as you say. Now, besides that, even today, it's estimated that about 50 million population is again going for the open air defecation. That is, 50 million population per year suffers from GIT infections every year, and approximately you can say 5 million deaths across the developing countries are due to the intestinal infections. Obviously, directly, indirectly, you may say. So this is the situation. So sewage disposal becomes a more important issue. Now, as we have seen in the textbook, the description that is typical sanitation barrier. That is, sanitation barrier is an important requirement because diseases from feces causing to humans. That is one thing. The five basic things which they have described conventionally, the classical description. That is the fingers, flies, water and soil and all these things. They are there. Now, sanitary disposal of excreta is important. The sanitary barrier between the human feces that is there. The sanitary latrines in the regular sewage system is it's important thing, and that will cause the barrier. Will achieve that barrier. Now, broadly speaking, there are two important modalities. That is the sewage system available in the bigger cities and towns, and others is something like you can say the smaller cities, smaller towns where we have you can say have a septic tank or something like that. So some kind of disposal is there. So this is how broad a description is sewage. Two descriptions are there. Now for the basic classification. The unsewered earlier, the historical, if we go historically, the unsewered areas had the PAL system, which is now bad. PAL system is something you can say it's a blemish. It is the something very you can say system which is now it was being criticized that Indians were criticized about PAL system because why human beings should be lifting the human excreta. So this was okay. And there were non-service latrines. They were introduced somewhere in about just about 100 years back. That was the borehole latrines, dug well latrines, pit latrines, and septic tanks and aqua private. This is not history is not very big, just about 100 years or so. Pulse system is totally out now. Something very disgraceful to if a human being is carrying human excreta. This thing. Now another system that was the camp and temporary systems, which were the shallow trench, deep trench, latrines, and borehole latrines, and all this thing. So what I will say here in this case, this pit latrines, septic tanks, aqua is basically the civil localities which are there. So there it is important. Then camps and temporary system, like some camping areas where people have been camping here, and temporary camps are there. In that case, shallow trench, deep trench, that means especially uh, soldiers or the people, men in uniform, they are moving. In that case, this is more use. And of course, borehole latrines are there. So there are two broad classification, and of course, the bigger cities, we have got a proper sewer system. Okay. Now, there is what about the regular sewage system for cities where the infrastructure is available? Water system, terrace system is also there, something like that. Sewage treatment, they have got sewage system is there. Now, once the sewage comes out, it is not the only question of only sewage which is coming out. It has to be treated properly. You just can't have like this. You have sewage and go flowing through the pipelines, and you discharge it in some kind of nala or a canal, or you can say river. It is not so. It cannot be done like that because it has to be treated. It has to be. It has got microbes, microorganisms are there. It's a regular, ready source of contamination and source of pollution. It is there, so it has to be treated. So the treatment is basically primary and the secondary treatment. And tertiary treatment, of course, now advanced methods are made available. As I told you, the treatment it can be go to that extent that BOD, that is biological oxygen demand, is as good as drinking water. So it has been polished to that level. Now, primary treatment in that it is basically that is the screening, grit removal, and the sedimentation. That's the conventional method. The screening is clean as basically the mesh is iron mesh through which the sewage is passing through, and the grit is removed. That is larger stones and larger objects, dead animals or anything, whatever is coming in bigger size can be removed, and subject to sedimentation, that is to a sewage treatment plant. Sedimentation will remove almost 90% the impurities, 90% things, or more than 90%, sometimes 99% will be removed. That is the part of the sedimentation. Then it comes to secondary treatment. Secondary treatment, we have got trickling filters and the activated sludge process. These are the things which are there. Trickling filters means what? Actually, some rotating, some object, something rotating things are there, and this particular sewage which is there in the secondary treatment plant, it moves and it mixes with the oxygen, atmospheric oxygen. Then there are other methods are this is there, sea outfall is there. Sea outfall, of course, that is the cities which are there in the seashore, they are there. Nonetheless, the treatment has to be done. The river outfall, of course, it has the river banks. Again, treatment is very important because unless treatment is done properly, it becomes a source of infection and it is certainly dangerous. So treatment is again very important. In the bigger cities, earlier it used to be there, like Ganga, Yamuna, Kaveri or other things, rivers are there, sewage was come, but now the legislations have come that now it has to be, before the river outfall, it has to be given, the treatment has to be given. So it becomes free from contamination. Then the sewage farming is one thing which was being practiced. Sewage farming is even large areas are there where the sewage farming is practiced in India. Now, of course, it has become less and less, but still it does exist. The sewage which is there, the huge areas of land are there where you can do the farming can be practiced. Although it's a dangerous method because precautions have to be taken, but the output is there. Because basically sewage means what? Sewage means large quantity of nitrogen is there. Active ingredient here is nitrogen. It is something useful for the growing vegetables and sewage farming. Of course, then there comes the oxidation ponds. That is another conventional method. Huge, vast tracts of the land are required where the sewage is spread over large area and exposed to the air, and of course the sunlight, air, sunlight exposure definitely, and the sedimentation process combined, the settle down, the solid matter settles down, and the sunlight and water have got the purifying effect, and once the effect is there, that is how the sewage becomes innocuous and usable. So now the unsewered areas. Unseen is the manual method, that is night soil and cars and all this thing. Of course, now it is being discarded. Now disposal is by basically unsewered area disposal is by the composting. The composting and the burial which is there, now it is going out. Now disease producing potential is always there because the human being is handling the human excreta. So that is there, and it is against the human dignity also. And our country, the parliament has passed a law that it is against the human dignity. It's been banned at PAL system. Then in the PAL system, the unsewered area has basically staff needed for the is also the large number of staff is needed, which is not correct. We have to pay them also. It becomes expensive. Then scavengers also expose the disease. All scavengers and Environmental Hygiene Committee also said no, it is not acceptable. And thereafter can borehole latrines. The borehole latrines came somewhere in the 30s, less than about 100 years or so. This was the first beginning of the treatment of the human excreta in a hygienic way. That was the beginning. Earlier it was the PAL system was there, sewer system, bigger cities, sewer system was there. And PAL system in the smaller cities were there, but there was no other viable method for the, of course, open air defecation was there. That's fair. But when it comes to organized way of handling the human excreta, system was not there. Now, somewhere in 30, the Rockefeller Foundation, the charity, they had done a lot of work in charity, the sanitation, human disposal of the human excreta, Rockefeller Foundation, as they said. And they had given they made the beginning, how first conventional way the disposal of the human excreta. They made a round hole was made that is 40 centimeters by, you can say, basically around is about 40 centimeter diameter, something about say 14, 15 inches, 16 inches or so, and 4 to 8 meters in depth. The special type of equipment was used, that is 20 feet, 25 feet depth and about 16 inches round hole. Open the seat was made. Digging by the auger equipment with the squatting plate was separate, which was put. Shifting the plate when it is filled up. So this was one of the things. It was useful. And family of it was sufficient. This typical round hole, that bit borehole latrine was sufficient for a family of 5 or 6 for about a year or so. And thereafter again you dig the another thing. Now, sludge digestion by aerobic process there, and 2 to 7 cubic feet of sludge for 1000 human days it was there. And sludge is of course harmless mass, and composting it could have been used. And only precondition for the borehole latrine was that we should be almost about 50 feet away from the source of any water. You can say well or uh, yes, it should be away from the water source. It should be almost minimum 50 feet away. So the sludge can be used also, and this was the borehole latrine, was the precursor. It's the beginning of the some organized way of human excreta disposal. This is a borewell latrine. This was there. We can see the RCC slab is there, and here the approximately 16-18 inches this particular this thing, and about say 18-20 feet or so the depth, of course. So this is the borehole, and that will be converted into the latrine. These sewage will be converted. That is, the human excreta will be converted in activated mass, basically by aerobic, anaerobic, essentially the aerobic digestion process. Then comes the dug well latrine, is a bigger version which came out somewhere in Singur district in West Bengal. Again, these agencies, the Rockefeller Foundation, all these Ford Foundation, and so many other foundations, NGOs are there. Those who have been doing a lot of work in this particular field, that hygienic disposal of the human excreta. That dug well latrines came in Singur district 1950. The pit was something like 30 inches, that is 2.5 feet in the, you can see the breadth. It was a larger hole, 30 feet. Of course, and thereafter 10 to 12 feet was the depth part. And sandy soil, because it was more essential for in the other normal kind of soil. While for the sandy soil, the digging was a problem, so it was 5 to 7 feet. It has a long life lasting about 5 years. Remember here the diameter is about 30 inches. 30 inches is quite a bit. On that you could fit the squatting plate and all those things, and the life was 5 years or so. Look, that is a borehole latrine. Here it is borehole latrine. There is squatting plate has been made, and the depth is something like 4 to 8 feet or so. For 4 to 8 meters, that is up to 24. That is a borehole latrines. This is an example. And now water seal latrines. Now question is, later on that used to generate whatever the latrines were there. They used to generate some kind of very obnoxious, say foul smell was there. That was a very important issue. Now they made it hand flush and water seal latrine. That was the concept which came. So idea was basically you are using for ablution, they are using water, and this you push some water there in the seat, and you have a water seal. And what is the use of this water seal is basically access to insects and other were denied, and there was no foul smell because water seal used to separate the, once it has gone inside the pit, the water seal used to cut it off from the environment, so there was no foul smell. Water seal preserved live breeding, also there are no foul smell. And PRAI, Planning Research Action Institute of, that is in Lucknow, Planning Research, and that is another institute, very important work, made very contribution done in Lucknow. One is the Singur district, as I told you, another is in Lucknow, and the RCA Research Come Action Project. These are few agencies which have done um, great service when it comes to the sewage treatment part is concerned. Now this is the concept of the water seal. Now water seal is approximately, the upper seal is approximately 360 millimeters. 360 millimeters, that means about 36 centimeters, or you can say the length portion of this particular pot is something 36 centimeters, approximately 14 inches is a pan. Now here is the water seal. Water seal, that is got a curved pipe. Here is the curved pipe and pipe connected there. Once you put some water here, the water with the gravity, this much portion, water will accumulate here, and this will deny the access. Once the sewage has gone ahead and the pipe connection to the pit or whatever is there, this will deny the contact with the insect breeding will stop. Secondly, this water seal will act as, you can say, this will prevent the escaping of the gases becomes difficult, so that becomes, if there is no foul smell, that is the advantage of this. Is the concept of the water seal. Now RC, Research Cum Action Committee, RC latrine, that is location, there are certain specifications they had said. See, the concept was basically to construct these, make it latrine should be available to the human beings, that is the facility for the individual families, sometimes a group of the families, cluster of the families, they made RCA latrines, and it should be viable that say couple of years that should last. And but very little, the concept was basically that should contain, have least or no maintenance cost, no foul smell, and of course it should prevent the insect breeding. That was the concept, and Research Action Committee, they made a lot of work on this. Now it should be 50 feet. That is the no. Now no non-flooding area 50 feet away. 50 feet away. What is the concept of 50 feet away? Why it should be 50 feet away? See what happens. The water table is there. Water table is there superficial, and the deep water table is there. So there is no possibility of any direct contamination of the water table. That is the purpose. The squatting feet was plate was something like 3 feet by 3 feet plate. That is 2 inches thick, as I told you in the previous diagram, and the pan length is approximately 17 inches, that I have described is 360 centimeters, that is about 14-15 inches or 17 inches maybe, and width is something like 5 in the narrow part, that is in the front, that is basically I am talking Indian type of latrine, and back side maximum 8. No, it should be, the basic idea is that 2 steps are also there, so for an individual sitting is possible. Then bent pipe trap is about 3 inches, bent pipe water seal is there, depth of the seal is about 3-4. So this is what is the water seal as I described here. This will separate the environment from the, this particular thing, that is the human excreta which is accumulated in the pit. This is separated, and there is no foul smell also. Yeah, there is a description. See what happens here, the water seal is very important. This pit is thing, and here is the pan which I described, and the pit, and here the water seal is there. This is 3/4 of an inch or so. This is very important thing because water used for the flushing, and once it is goes out, the this particular thing cannot come here. Foul smells cannot come here. There is escape pipe is also there for the, because by anaerobic digestion or aerobic digestion, whenever the sewage is being or the human excreta is being treated, in that case some gases are bound to come out, but definitely they will not come out through this water seal. That was the advantage. Then come the Connecting pipe about 3 inches pipe, minimum 3 feet length, the bent end, dug well. Now dug well is same as dug well latrines are there. The RCA, PRAI, all these things, they have the same principle, but different, say Lucknow, Singur, different places work was going on, and they said basically it is something like 30 inches the breadth, and 30 inches quite a bit in the diameter. Earlier, the borehole latrine, remember, this is 12 to 13 inches, 12 to 14. Now, 30 inches quite a bit, and that used to depth used to be quite a bit, something like 8 meters. That means about 26 feet. Here, length is about 10 by 20 feet or so. Acha. Now there is a superstructure. Now there is a superstructure which is there. Okay, now comes the connecting pipe, that is 3 inches pipe, minimum 3 feet length of the bent end. So dug well is small, that is I told you that 30 inches and by 10 by 12 feet. Then there is superstructure. For superstructure, as I told, plate is there, the WC seal is there, and for the privacy from the protection from the rains and all this thing, you got to have a superstructure like a small room or contain is there, and some privacy is required. In this case, maintenance is important, because again cleaning of that general area is that plate is also important, because you can't keep it dirty like that once you have fitted the piece. Like borehole latrines, you remember, there was hardly anything, because directly the street was falling into it and it was covered. Here in this case you have, but foul smell issue was there. Now in this particular see these kind of latrines, water seal latrines are there. In that case, foul smell cannot escape because of the you can say water seal. Here, some maintenance is definitely required, cleaning is required in this. Now, septic tank. Septic tank is a very important development, very important advancement which has occurred in past century or so. Now, it's a watertight masonry structure. It is like a cement structure, it is there, and many houses may use one septic tank, can use it. And actually, when we those smaller cities where though there is no specific such kind of regular sewage system is not there, septic tank is ideal. And now there are 2-3 compartments. Basically, 2-3 compartments is basically kept to, so that movement of the sewage is very slow, and it gets the opportunity for the aerobic as well as anaerobic digestion. It is covered on the top by a manhole is also there. So space and the volume recommended is something like 2.5 to 5 cubic feet per person. So it is basically it is worked out because 2 or 3 families may be using it. In that case, 2 or 3 families when they are using, in that case they have to work it out. Now, minimum capacity has to be something like 500 CFT. Minimum capacity is something like 500 CFT. So 5 CFT per person per year, it's okay. So once in a year or so it can be cleaned. The length breadth ratio is rectangular, not exactly square. It is a rectangular length breadth ratio is there, and approximately 2:1. That is the normal, and the depth is also there. Now here is the principle of this particular thing. That is the inlet pipe. This is the septic tank. The septic tank, it has got compartments are there. Compartment divider 2, maybe 3 also. So the movement, say it is from where the tubes are there. Inlet pipe is from, that is it is connected to the sewage, that is WC, that is Indian type or whatever inlet pipe, and it moves here, and different baffles are there, and gradually it moves like this, and it from here it moves like this, it moves like this, and again comes out here, it comes out. Sludge is deposited here, and the water which is there, because water is also used, the outlet goes to the water, and the this particular herringbone pattern or some different type of patterns are there. In that patterns, this water goes into perforated pipe is there, it is going to the soil, and soil absorbs it, the water extra. And of course these are the tubes are there, and tubes are inlet outlet for the gases which are produced by the anaerobic aerobic digestion which is there, it is there. So this is the principle. And whatever the after digestion of the human excreta, whatever sludge is there, it starts getting deposited here. Of course, over a period of time, the sludge has to be cleaned. It cannot be continuous affair. Maybe depending on number of users. I told you like 500 CFT is the use. Now 2.5 to 5 CFT per person per year, something like that. They work out, say, a couple of families that they are using it. Say about 25 members or 20 members are using it. So yeah, but it has to be cleaned because sludge will deposit and it will get filled up till here. After some time, it has to be cleaned also. So that is the basic principle of this thing. Now here the question, how it works. Basically, it's a anaerobic and aerobic digestion. It is there. The scum here comes out, scum is coming out, gases are escaping here, outlet pipe is out there. So that is the principle, and it is connected to the latrine. Okay. Now come the airspace minimum 12 inches is must, because what happens, septic on the top level and the water is accumulated there, it has to be 12 inches in the must. Over a period of time, what happens ki the sludge keeps on depositing, so this space becomes less. In that case, septic tank has to be, inlet and outlet pipes are there, bottom sloping toward the inlet end. So why it is bottom is sloping toward, because more time is given for the sewage to be digested and remains there for more time. Facilitates the collection of the sludge. Retention period should be minimum 24 hours. That is the thing, because you have made the partition, so the movement is not so fast. Scum of the fat, lighter solid, they float. Now sedimentation, the bottom anaerobic digestion is there. On the surface it is aerobic digestion. Then perforated pipes are, that is herringbone pattern, they follow. And the perforated pipe, there is an outlet is there. Outlet side, it goes beneath the surface of the soil, beneath the surface of the land surface, and it is absorbed there only. So that is the thing. Now, effluent pipe, it should be at least 3 feet deep. Why 3 feet deep? In the sense, of course, because water, the uh, land should not get waterlogged. So that is 3 feet depth is there. Absorbed soil. Now, it is water is absorbed by the soil, and ova and cysts are destroyed. If it is getting superficial surface, ova will survive. Deep, it will not. Anaerobic and aerobic both process digestion occurs. It is one more precaution has to be taken, because the most importantly, avoid soaps and detergents. What is important in this particular septic tank, detergent should not be used, because detergent or the quaternary ammonium compounds and all these things, because what happens, they interfere with the aerobic and anaerobic bacterial digestion, so they should be strictly not used, you interfere them. And desludging is done once in a year or so, so you can make out, suppose 500 cft is the area, and we want to have something like 2.5 to 500 5 CFT per person is the using. Suppose 100 people are there, so and the capacity is something like 500 CFT. So that should last for a year or so. That's very important. And the new septic tank and the old sludge is added. Now this, yes, this is very important thing. What happens is sometimes the sludge is not a useless thing. It's a complex structure, a complex thing which has got billions and billions of, you can say, the human excreta digesting bacteria. It can be used as a seed for the whenever there is a new septic tank is created. From other septic tanks, the seeding can be done. Of course, the sludge is not a useless thing. It can be used basically for composting and other thing, land filling. There are so many uses are there. But most importantly, it becomes free from bacteria. Digestion process will kill the bacteria, ova, cyst, viruses, and all these things, they are killed, and it becomes innocuous mass. That's very important. Aquaprive, some principle of the aquaprive is same, like septic tank. Here the only difference is the capacity is also quite a bit. Basically, aquaprive is useful for the, you can say, the common latrines are there. Now, it directly receives excreta, that is, it's approximately 35 CFT size from the family, you can say lasts for up to 6 years or so. Then again, it is the process of digestion and anaerobic process. The only difference I told you, the directly receives excreta means what happens, septic tanks, there are 4 or 5 or more lateral pipes are joined with the one particular septic tank. While in this case, Aquaprive, it is the only single family, single dressing is there. So cost is about, say, up to 35 CFT, they say different sizes are there. It is only an example. The family lasts for a few years or so. Vent pipe is also there for escaping the gases, because in the gases, escaping the gases will be generated by the anaerobic aerobic process, and essentially it is methane. Yes. If it is methane in gas, can be used for the energy fluids. Now, outlet pipe is same principle. The outlet pipe is there. It's the same principle. It is 3 feet below the ground, and whatever outlet water is coming out, it goes into the soil and it is absorbed. That is there. Okay. Now here is the septic tank. In this aqua pipe, it is a huge thing, huge tank is there. Only pipe is there, privacy, there is an outlet is there. And the scum is coming out here. Here the outlet pipe is there. It is the inlet pipe is there. This laundry basin is there. The sludge is collected, and again it has to be cleaned over a period of time, say once in a year or once in 2 years or so, depending on the number of users. And the outlet pipe is say land surface, it is 3 feet. The depth is approximately less than 3 feet depth is there. So it is the vent pipe. The vent pipe is basically escaping of the gases, and well, methane can be one of the byproducts. It can be used for the energy also. Sulabh Shaushalaya is a recent concept which has come up in last 2-3 decades or so. Now today we are in say 2022, and it is something, it has started somewhere Sulabh Shaushalaya just about say 3 decades or so. Recent concept, still it is there. Swachh Bharat, of course, it was there, but after the Swachh Bharat Abhiyan, that is in 2014 onwards or so, it has gained importance. Essentially, it is an RCL, research and action project, that latrine with a water seal and connected to a pit by 3 by 33 by same anaerobic process digestion. Sulabh community latrines are there, bathing block. Okay, now Sulabh Shaushalaya complex. It is Sulabh Shaushalaya complex is the typical complex which is there. Again, water RCA type of latrines are there. Different you now we are lakhs and lakhs of this thing that created a facility with the most hygienic way of disposal of the human excreta which is there. So it is a useful thing which has come up in a big way. Now chemical closet. Now chemical closet is steel tank containing the formaldehyde or some coloring agent, the deodorant, small capacity, basically directly receive the excreta and disposes of these small quantities. Basically it is useful something like aeroplanes or something, some places where it is regular exposure is not possible. Mobile thing is there, it can directly disinfection of this disposal can be done. But it is only for the very small capacity. I should not call it as a very hygienic thing because you are using formaldehyde. While anaerobic digestion, aerobic digestion of excreta is very important thing. It is very definitely very useful because sludge is there, free from chemicals. It can be used for other purposes also there. Methane is generated. While in this particular thing, nothing is being generated. All the same, it is smaller collections, smaller facility. Yes, chemical closet can be used. Like mobile sort of latrines are there. Some fair is there, some small community gathering is there. There it can be useful thing, and the quick disposal and the hygienic disposal, the safe disposal, it is useful thing. Then comes the shallow trench latrines. This is for the camps. Like these are the use for the uniform people, that is security forces are using it because they have to move. Like say for example, you can say for camp like line of control, there are certain camps are there where you cannot make them shallow drain latrines. I mean like CRPF, BSF, and all these places. The movement is there. They're basically 1 feet wide, 3 feet depth, and length is about 10 to 12 feet. And this earth is piled up over used for the cover. That mud can be covered for the excreta, and a lot of disadvantages there because left only for one. Now once it is the depth is approximately 3 feet. Gradually the people use it after the seat is fixed over the shallow trench latrine, and when the from the ground surface, if it is less than 1 feet the space is left, then it is filled up, then again you have to dig up the another shallow trench latrine. It is not a very hygienic thing, but definitely for the uniform people in uniform, men in uniform, while moving, while on the march, couple of days they have to use it, then shallow trench latrine is the only viable answer. Deep trench latrines are basically meant for, it is something same principle, similar principle as a shallow trench latrine, but here the that also in the military jargon it is known as DTL, deep trench latrines or so. So it is about 6 to 8 feet depth. So depth is you see more, and the width is also more, and the variable length something 10 feet, 12 feet, and upper superstructure is there. 3-4 seats are made on that, and partition is made. Superstructure plate fitted on the top, and superstructure is a wooden and tin plate, and holes are made on 4 to 5 holes and squatting footprints and something same like they have made something like, because what happened, such kind of 6 to 8 feet deep trenches there and 30-35 width is there. They have a superstructure. They, instead of using individual plate, they put a huge structure, wooden plate, wooden thing which is there, and it has got holes, and some small outlet doors are also there, so it can be used closed after the use. and the minimum water is used for the ablution. But deep trench latrines are basically used by the security forces when the stay is more than say 4 weeks, 6 weeks, like that. Deep trench latrine. Once it is used is full, again it is filled up and they move on to the other nearby place. The water carrier system. This water carrier system is the most method of choice that is bigger cities like you can say Mumbai, Hyderabad, Pune, Indore, like that. Method of choice modern that sewage is connected to the water carrier system. Maybe combined with the surface water or it can be separate. When it is combined used, but see, water basically there are three things. One, one is the you can say you can the surface water. Surface water means what? The flushing or washing and all this thing and the roads and all this thing. That is the surface water. That is the one way, or the you can say the storm water during the rainy season. Another thing is important here is the you can say that sewage. That is the sewage means kitchen waste. And third is sewage. It can be separate and same also, but it is ideal is separate, of course. Calcutta was the first system which developed the sewage system in 1867. Imagine 1867. That means more than 155 years back. Mudliar committee, which was committee reported in 1962 that it should be there, and only 15% India had access to sewage system. Very heavy financial outlay is required because laying down sewage line is a very expensive affair. Although it lasts for 30, 40 years or so, but the initial expenditure is quite a bit. Now, components are there, housing, sanitary fitting are there, like we have toilets in the apartments, we have a toilet, individual sanitary fitting, then the house sewers is there, house sewer, the street sewers, trunk sewers and sewer appurtenances, manholes, etc. As you have seen in the bigger cities, manholes are there, it has to be regularly maintained, cleaning is also required, and it lasts for 30, 40. Now, household sanitary fittings are commode type water seal latrines, something like water seal, like just about WC, the Indian WC, and 4-inch house, that is basically 4-inch standard house drain is there, and of course they function on the water seal principle. Now, public sewers about 9 inches to say 12 inches, and minimum they have to laid about say 10 feet below the ground level. It's important. Why it is 10 feet below the ground level? For a simple reason, the cross connection or the cross contamination of the water, drinking water should not happen. So it has to be minimum 10 feet. And there are manholes for every 100 meters, they have to make manholes. Like manholes, you must have seen somewhere, manholes are important because maintenance is very important. Unless it gets, no, gas bagging is another hazard for the workers because a lot of methane gas is generated out of it. So gas poisoning is important hazard for the workers. And the life is approximately about 25 to 30 feet, but usually it is more than that. Usually it can be used something like 40, 50 feet for 50 years or so. Now, sewage means basically human excreta. Sewage means kitchen, bathroom. As I have told you, bathroom waste about 99.9% is water. Danger of the nuisance, unpleasant odor is important thing which is there. Then vector breeding, pollution of the soil, contamination of food, and all these things. Hence, the in the bigger cities, sewage treatment, proper sewage water carrier system is important. And the feces generated is something like 100 grams per day per person. So that you can imagine a city like say something like Mumbai or Pune, where the population is in crores, how much feces or how much the sewage, human waste is generated. And just imagine one particular gram of the this thing species contains 1,000 million E. coli or something like streptococci 10 to 100 million per gram. So that is the number of microbes which are there. So the treatment has become very important thing. And the apartment, when there are say 200, 300 people are staying in one building, and the sewage amount of sewage generated and how it has to be treated. So it is a very important, a huge thing which has to be managed now. Now, why sewage disposal treatment? Because impure bacteria or eat away the oxygen. Sewage, when mixed with the water sources, contamination, pollution of the water is there. River nala, you cannot put in the liver or nala because we are contaminated. Their flora is affected. So infection spreads. Then offensive smell is there. And the stabilization of sewage and safe disposal is a must. And the oxygen demand has to be brought down and should become innocuous by reducing number of bacteria. And of course, the solid things have to be taken out, and the whatever sewage is finally getting into the river or the some kind of canal or whatever it is falling, it should be free from bacteria and the innocuous agents. Okay. Now comes the BOD and CAD is three measures to determine what all the sewage contains. The sewage, what is the sewage is there? See what it contains. It generates biological oxygen demand is there because of basically the human waste is there that will create the biological oxygen demand. Biological oxygen demand is basically it is directly proportional to the organic impurities. That is a separate subject by itself. To give an example, I will say that drinking water should have less than say 3, 4 or 5 biological demand is something like 3, 4 or 5 or so. So in this particular case, sewage is something it runs into say few hundreds. So potable water they say 1 to 2 ppm or something like that. As told you, potable water. While weak sewage now in the sewage has got 100 ppm in the weak sewage 300 ppm and above is a very strong sewage is there. It may run into thousands also. So that's it. So basically, what is BOD? Biological oxygen demand is the number of impurities because of the sewage what is there inside, and the moment it is treated, the biological oxygen demand comes down, and it becomes as good as you can say usable potable water. And that is the aim basically in the Western countries, developing nations. They have achieved that. The primary treatment, secondary treatment, tertiary treatment. After tertiary treatment, the sewage is the biological oxygen demand comes to 1, 2, 3, 4 or something like it is as good as drinking water free from bacteria. Although it sounds dirty, but this is what it is. They have been able to achieve it. Nonetheless, if not for drinking, it can be used for so many things, other things like gardening, washing of cars and all this thing, it can be used. So this kind of thing they have achieved now. Now, COD to measure oxygen demand in other than toxic chemicals, important industrial, that is chemical oxygen. That's a different subject. Oxygen, suspended solid like industrial waste. Industrial waste they use it for COD, while for sea waste they use BOD, ranging from 1 to 500 beyond. That's there. Okay, now decomposition of the sewage matter is by aerobic as well as anaerobic process. Anaerobic process generated ammonia, that is methane, may be a useful byproduct for the heating or the energy generation. Modern sewage system, very important advances now. Basic steps are primary, secondary treatment, grit removal, screening of the sedimentation, aerobic digestion followed by the aerobic oxidation. It is there. Now, what is this? Now have a look at this. Now here it is basically the pre-treatment is there, the overflow is called pre-treatment is trash which is there, air is mixing with the air. Okay, now mixing of the air, thereafter it goes to the primary treatment. Here the rotors are there. These rotors are basically what happens given the rotors is there are this container and they're mixing with the oxygen that will lead to aerobic digestion of the sewage. Then aeration tanks are there. From aeration it goes to secondary treatment, and finally after secondary treatment it goes to sludge digestion. Sludge is digested. The sludge can be good product for the manure, landfilling, etc. It can be useful thing as well as if it is producing the gas. Gas is also very important in the form of methane, which can be used for the energy requirement also. Then the dry sludge is there, which can be used for other purposes. Like as I told you, main is the manure, landfills, and so many other things. It can be used. That's it. Now comes the primary treatment. The screening is 2 inches fixed, moving mesh is there. Grit chambers about 10 to 12 meters long, slow moving. The grit is passing through, the sewage has to pass through some kind of grit chamber. And solid products which are something like you can say it is like flow is something 1 feet per second, very slow, and the grit is removed by the sedimentation as well as you can say the mesh is there, that will be stones are there, wooden particles are there, cotton swabs are there, some kind of so many things are there, maybe sanitary napkins are there, so many things that will be removed. And the sedimentation is a huge long tank. As I told you here, again 1 feet, again the movement is 1 feet per minute. Sedimentation removes almost about whatever sewage, normally as I told you about say 1 or 2% or maximum 3% of the solid matter is there. So almost about 90% of the solid matter settles down. Sewage moves approximately 6 to 8 hours, movement is there, and 50 to 60% solid gone and 50% bacteria only by sedimentation they go down. Sewage moves in sedimentation part. Now fat and scums may be removed and the okay. Then comes the secondary treatment. There are trickling filters are there. You see the diagram which you see. The water is trickling like sprinkled over a surface. Activated sludge process. The trickling filter, percolating filters are there, and it's about approximately 8 feet deep and up to 100 feet in diameter. and filled with stone, sinkers and all this thing. Sewage comes down, and that's particular thing. Similarly, it mixes with the oxygen. It mixes with the oxygen. In that case, oxygen mixing that will lead to anaerobic digestion. Like zublier layer is formed, which bacteria organisms are digested. With the zublier layer, as that you might have seen that slow sand filter. Similar thing, it is something like algae or some kind of biological layer is formed, which acts as a filter and also removes the impurities and digestion, and the biological responsible for the digestion of the process, something like human excreta. In this case, same thing is happening somewhere when we are treating drinking water purposes. We are treating water in the slow sand filter. Something like zublier layer is same, which is formed in the trickling filter, and this helps the purification. That is, maximum number of solids impurities are removed or oxidized. Okay, activated sludge process. Aeration tank is there, primary sedimentation tank. Sludge is mixed with the help digestion, and mixed activated, so 30% rest effluent comes out. Allowed to spend about 6 to 8 hours time is there. Secondary sedimentation, sludges, aerated sludge is very useful manure. See, the whole process is something you can say slowly moving the this thing. First, slowly moving the sewage. The first stage you must understand, that is the screening, the removal of the grit, removal of the stones. These things are happening, and thereafter it is slowly moving ahead. And aerobic digestion, anaerobic digestion is occurring, and trickling filters is there. Trickling filter is again mixing with the oxygen, that is atmospheric oxygen. Again digestion occurs. Then there is a zublier layer is there. Zublier layer, some kind of this will also do the digestion of the bacteria and removal of the solids. It is there. So this is a slow process, and gradually the water, the content, the impurities level, or the sediment, either the sediment or the filtered out, or they are digested. Simply it is happening. Now activated sludge process, again sludge recycling is done here. Again the sludge slow movement is occurring, mixing with the air, and aerobic digestion which is happening there. The activity, aeration basin is there. Secondary clarification, sludge is coming down, and sludge is again recycled. So again it is used for the aerobic digestion. This is the principle behind it. Now, 1 gallon of sewage produces about 1 million gallon of sewage produces. See, quantity is very less than 1 gram, 1% or so. So it is 1 million gallons of sewage produces something. 1 million gallons is something like 45 lakh or 50 lakh liters. That will produce 50 lakh liters, will produce only about 15 to 20 tons. 15 to 20 means approximately, you can say 15,000 kg or 20,000 kg. While here millions, 20,000 kg, where it is 1 million gallons, means say about say 45 50 lakh, 50 lakh and coming down to 20,000. So it is even less than 1%. It will approximately 45 to 50 lakh liter produces that much, about 20,000 of sludge of this thing. 95% of water gone now, sludge digestion for the few weeks, and by dilution, the disposal of effluent is a big issue. By dilution in the river, that is river now it is free from bacteria, and most of the impurities are gone now. Now it is badly in liver. BOD must be brought down to 200 ppm or below, and suspended solid must be brought down 30 ppm. River will produce approximately 8:1 dilution factor. Disposal is difficult for COD, chemical pollutants, because chemical pollutants are different. Biological oxygen demand is different thing, while here it is a different issue is there, because chemical pollutants are maybe any kind of chemicals. It has to be degraded. Now stringent international regulations are there. Okay. Now developed world, they have got drinking water standard, they have brought them. Now sea outfall, another matter, river outfall. The land treatment of the sewage farming is another thing. Requires the huge land is there. 1 acre per 300%. Imagine the requirement for the city like Indore. So requirement of land is quite a big. Farming purposes it can be used. Maybe banana or something like some kind of plantations it may be used. Oxidation ponds are there in them. We have about 550 cities oxidation pond, waste stabilization pond. Basically water is spread over the large area, and it comes in the contact with the air and the sunlight, and by this is approximately 3 feet deep or so, and good sunlight is a must in that area. An aerobic process, this treatment is there. Size of the pond may be something like 20 acres or more. Requires a lot of maintenance is required in places like Indore or something like Bhopal or other places. the amount of requirement of the land is quite a bit, which may not be available. And although sunlight is there, but land requirement is there, maintenance is required. Oxidation pond is useful, but not viable in their places which are thickly populated cities. So this is the principle. Sunlight is using it, and the air is mixing with oxygen, bacteria, all things are digested, and the raw waste can settle down, and the sewage, the scum can be used for the land. The basic principle. The only constraint is the large area what is required. Now, oxidation ditches, aerated lagoons are there, require less space. Lagoons are required 2.5 acre minimum, 1 acre, so suitable for the small communities, small villages which is there. So we conclude here, basic principle that what we have to bring out here is the sewage treatment is a very important activity which is very much required, because the water has to be rendered, that the sewage has to be rendered harmless, contains bacteria which contains a lot of contamination, and we cannot allow the contamination to mix with the drinking water. Then secondly, the breeding of the insect is another issue which has to be taken. So safe disposal of sewage is important. There are two, three things which are required. One is the latrines part of it. Another part is, well, of course, the sewage, that is the bigger cities, we have got sewage treatment. But in the Western world, they have achieved the primary, secondary, and tertiary treatment. As I told you, it is as good as drinking water they have achieved. And that is our ultimate aim. And the Sulabh Shauchalaya has achieved quite a bit. And I think this movement will, if carries on, we will be achieving good results. Thank you. I conclude here.